Hi everybody, happy Monday, we're back. I am starting new material as far as graphing quadratics, but we're going to review graphing linear equations first, and then I'll also post a video on graphing quadratics. I'll keep these videos up, they're not going to be taken down, so next year when you move on to Integrated Math 3, you can go ahead and come back and review these if, say, it just, you didn't have the normal classroom environment, but I'm happy you're with me. I'm happy you're learning. So this is from Integrated Math 1, even middle school. So we're just going to go ahead and review those and move forward, and then we'll go ahead and move into graphing quadratics, like I said. And once we learn them, solving them, graphing by hand on graph paper, then we'll go ahead and move on to Desmos, which is an app that you're going to upload to your phone. Okay, so here we go. Miss you guys. Okay, we are going to review graphing linear equations. So this is slope-intercept form, y equal mx plus b, right? B is a number, fraction, decimal, integer. M is a number, fraction, positive, negative, integer, right? Positive, negative, or decimal. So the m is your slope, and that is the change of y, delta y over delta x, or change of y over change of x, which is the formula y2 minus y1, x2 minus x1. And so, you know, if it's positive, you move up, negative down, positive right, negative left. So this is review. We did this last semester. Okay, the y-intercept is the b. So how do you find a y-intercept? You let x equal 0, and then you go ahead and solve for b, and that number is the location where the linear equation, the line, intersects the y-axis, right? Okay, so this is review from like 2 years ago for some of you. All right, we're going to go ahead and graph these linear equations. The paper keeps wanting to fold up. All right. Y is equal to negative 2x plus 6, y is equal to 4x minus 1, y is equal to negative x, and y equal x plus 3. I tried to get all the variances. I didn't choose fractions because we are in kind of an unusual situation. Remember, this is for the point of us using an XY table, plotting points on a coordinate system for the benefit of moving on to graphing quadratics. So this review is definitely tailored to us moving forward, okay? All right, so here we go. It's called the slope-intercept form because it gives you the slope and the y-intercept. So yeah, it's pretty self-explanatory. Okay, so the slope, which is m, would be negative 2, correct? So my slope here is negative 2. My y-intercept is my b value, right? And so that is 6, positive 6, right? Okay, now for those of you that can not necessarily, you need to go over the XY table and you can just go straight into this coordinate system and you understand the shortcut of rise over run. So you would understand that if the b value was 6, so you would move up, so these are incremented by 1. 1, 2, 3, 4, 5, 6. You understand that that y-intercept means that there is a point at 0, 6. And then that slope, negative 2, you understand that my numerator is negative 2, however, my denominator is positive 1, so I would go down to right 1. I don't want to completely, once we solve it with the XY table, I'll go ahead and go over that. But then you would just start at that y-intercept point, and you would move down 2 units and right 1, and then that would be your next point. And then you would go down 2 units and right 1, and then you can keep going down 2 units, right 1, and you would go ahead and connect these points. Now we're going to go ahead and get that line, but we're going to do it the appropriate non-shortcut way, because remember, we're graphing quadratics and there is no shortcut. You have to complete the XY table, and so that's why we are going to do this. So I'll do the first two on one video, and then I'll jump to the other two on a second video, just because so the video is not so long, because I'm already into 5 minutes. Okay, here we go. Just pick numbers, right? You don't have to get fancy. We're going to pick input numbers, right? X is your input, Y is your output. So once you pick the number for X, you will substitute. You will follow order of operations, right? PEMDAS, and you will go ahead and do this arithmetic, and you will get a value, and that will be my output, right? All right, and then those 2 points create those two numbers create a point, a coordinate point, and we'll write them out and then we'll plot them. All right, so we can pick a negative. So I'm just going to make them. We're just going to, remember, we're graphing on paper, so I do not want to get too far away from the origin, right? This is 0, 0. I don't want to pick -5 because then I'm over here. I don't want to pick +10 because I'm way over here. We're just going to be somewhat careful and just stick to the origin. So here I will just choose, we can just choose -1, 0, 1, 2, right? We can just go ahead and just stick to those numbers. Okay, so here's what we would do. We would take this x equal -1, and we are going to substitute it into this x variable, right? Because remember, here's the variable x, and these are the numbers that we're allowed to substitute. So if I let x equal -1, I should have put way more paper. Here, let's do this, because I realize, yeah, I don't think I'm going to be able to squeeze it in. So let's do this, and let's make it nice and neat. Okay, so we are going to let x equal -1. If this is the given linear equation, I'm going to take that -1 and I'm going to substitute it here into this x variable. So if I rewrite, y is equal to -2, -1 plus 6. And now you're going to multiply, right? Parentheses, whoops. -2, we're going to multiply. And so that product is +2, right? A negative times, a negative is a positive, plus 6, and so I get 8. So that is my output number. So when x is -1, I get 8. I might have gone off the chart. I'm probably going to have to plot like right here. Okay, now let's x equals 0. So now let x equal 0. Y is equal to -2, 0 plus 6. Take this product, I get 0, right? Any number times 0 is just 0, so I'm left with 6. And so that is my output Y value. So here's 6. So now let x equal 1. Substitute the 1 value where you see x. So this is just very repetitious. We're just same thing over again. The product is -2 plus 6, and I get +4. And if you're not sure about that, there's no shame in verifying on a calculator. So -2 plus 6, there's my +4, right? Not 8, it's 4. So I fill it into my XY table, and now let's just do one more. And you only need minimum 2 points to create your line, but remember, we are practicing for the point of the quadratic, and for the quadratic you need 5 points. So I just want to make sure I don't mess up. So you got to be willing to put in the work. No complaining, got to put in the work. Okay, the product of -2 times 2 is -4 plus 6 gives me 2, and so here's my 2. Okay, you can also throw all of this into the calculator. So if you substituted that 2 here, you can type -2 parenthesis 2 plus 6, and this calculator will also calculate it for you. I can take, whoops, don't do that. -2, 1 plus 6, and there's my 4. Okay, so as long as you know how to use your calculator, you're successful as well. Remember, garbage in, garbage out. If you're getting a wrong answer, then you're probably punching in the buttons incorrectly, or you might be using the subtraction button instead of the negative button. Okay, so now what are our points? So we computed this work, so I'm going to move it to the side. All right, so here, that's going to bother me now. Yes, it's going to bother me. So I'm just going to cross it out. My apologies, it doesn't look as pretty anymore. This XY table produces coordinate points. This is my X coordinate value. This is my Y coordinate value. So this is the point -1, 8. This is 0, 6. This point is 1, 4. And this point is 2, 2. And now you're going to go ahead and plot them. So -1, here's -1. So the first number is X, right? This is my X-axis. This is my Y-axis, right? So these are my axes. Axis, singular, axes, plural, but okay. So -1, 8. So here's -1. And now I have to go to the Y value of 8. So you can follow here. 1, 2, 3, 4, 5, 6, 7, 8. I'm barely off of it. So -1, 8 is up here. 0, 6 is here. 1, 1, 2, 3, 4 is here. Yeah, I'm right. Okay, 2, 2. I thought I mixed the 2 points. 2, 2 is 2, 2 is here. Okay, so this is our line. I don't know how I'm supposed to do this one-handed. Use an elbow. I'm gonna set it down really quick. All right, so if I... This is not good. Okay, I'm gonna set this down really quick. That looks terrible. Okay, so you connect and there is my line. All right, for those of you for the shortcut, the rise over run, yes, you were accurate. Yes, you can solve it that way. But remember, we are for the point of graphing quadratics, and there is no rise over run shortcut. So you better know how to get these numbers. It's crucial. You got to know how to get these numbers. You have to know how to substitute. You have to know how to plot, and then you get your graph. And it's pretty basic, okay? All right, so here we go. Had you done it the shortcut way, my y-intercept is 6. That means 6 is where it intersects, the line intersects the y-axis. So if you come to the graph, you find 6. This is then your starting point. Okay, my slope is now -2. So if your slope is -2, then your rise over run, -2. Remember, every integer is a fraction. The denominator is 1. If you don't see it, it's really there. It's 1. So that means my change of y is negative. So I would go down 2 units, and this 1 value is positive. So I would go right 1 unit from this y-intercept. So from 6, my y-intercept, my b value, I would go 1, to move down 2, right 1, there's my point, and then repeat. Downward 2, right 1, there's my point. Downward 2, right 1, there's my other point. And although I stopped, it would have continued. So my line looks really nice. Or you can go the opposite direction. So if it's right 1, down 2, you can move left 1, up 2 if you have to go in the opposite direction. And that's it. That is solving a linear equation. Okay, go ahead and try these 3. And then I'll create a video with the 3. Take a picture of your work, send it to me. Remember, on the assignment in school loop, you take a picture and then you can send it there, and it opens up really nicely for me to put in your credit. But whatever's been working with you, if you've noticed that I've put in points for you, for an assignment, then just do what you're doing. If I've had to comment and send back to you that you need to resubmit it to me, it's because it's taking me, if it's a link, it's taking me somewhere else, and it doesn't open. Like sometimes it opens on my phone, but it doesn't open on my laptop. So just take a picture, go to School Loop and send it that way, or just continue what you're doing if it's working. Go ahead and do these three: y equal 4x minus 1, y equal negative 3x, and y equal x plus 3. But if we just kind of start you on this, just to make sure, this one's not a big deal. There wouldn't be any confusion. My slope is 4, my y-intercept is -1. Okay, here though, these two. My slope is -3, correct? But what would be my y-intercept? And this is where, if we were in class, I would look around and say, anyone? What is it? And kids would tell me 1, and they would tell me 3. And then, of course, a good portion of you would say, I hear zeros, yay. Okay, and it would be 0. So this is actually plus 0, and we will have those in the quadratics. So that is super important that you understand your value is 0. Okay, and then here, same thing. You would all tell me about my y-intercept being +3, but then I would then ask, if we were in class, anyone, students, what is my y-intercept? And I look around and I call on someone, and yes, you are correct. It is +1, right? Okay, so if we were going to be super extra, it would be y is equal to -3x plus 0, and this linear equation would be rewritten as y equal 1x plus 3. So if that makes you feel more comfortable, by all means do that. Ones and zeros can cause a little bit of confusion in mathematics because we assume that you know that we know what's should be assumed. That's essentially it. Okay, so go ahead and there you go. Get these graphed, and then I will shoot another video with the answers, and then I'm going to shoot another video with the quadratics. I'm trying to get this so you guys can see, but I know you can pause it. Okay, and by the way I drew my coordinate systems is I kind of favored, I knew where, like which quadrant the line would exist, and so that's why it's more favored in 1 and 2. Here it's favored, and then here it's favored. So yeah, that's why. But if you want to go ahead and graph them on the same coordinate system, you can, but then use different colors so that you can let me know which line goes with which. So color code them. And remember, put your arrowheads, label the y, x. Do not be lazy. Like, look, these are so detailed. It has my increments. I tell you that are incremented by 1. Do not assume that I know what you are graphing. You need to tell me, okay? Because when we move into the quadratics, it's important that you tell me what you're doing, because I'm going to show you what I am detailing, which helps you learn, okay? It's really good to see you guys. I'm going to set up, I'm looking forward to seeing you. Today I'm going to send out an email with Zooms as far as by periods. So period 1, period 2, period 3, period 5, period 4, period 6. I'll send out a Zoom. It will have an invitation. I'll have to get different times going. And I want to meet up with you. So I'm hoping you have the Zoom app, and we'll just go by there because I'm allowed 40 students for up to 40 minutes. And I won't be teaching when we meet through Zoom. I won't be teaching. You can ask questions, clarifications, but it'll just see how you're doing, see your faces, see your smiles, hear your voices. I miss you. So I'll get that email out today, and then we'll just start meeting up every day. Just if you're welcome to join in here and there, twice a week, 3 times a week, 5 times a week. It's up to you. Okay, but I miss you. Okay, have a great day. You'll be seeing me again. Bye.